Welcome to This Explainer. Today, we're diving into the absolute ultimate mystery of the human experience. What actually happens to our consciousness when the lights go out? We're going to look at the fascinating biological intersections between sleep, clinical death, and, well, the age-old concept of the human soul. So stick around because it's a wild journey from the everyday act of just going to bed all the way to the absolute edge of existence. Think about it for a sec. Every single night, we do something that is, honestly, incredibly strange. We just willingly lose consciousness. Our minds seemingly vanish, our muscles go completely limp, and we spend a full third of our lives in this bizarre, vulnerable state. But where does your mind actually go? Is it just, powering down like a laptop, or is it traveling somewhere else entirely? Well, let's dive right into this and look at the fundamental difference between sleep and clinical death. This is an existential comparison that has literally terrified and fascinated us humans for millennia. If we look back at the ancient Egyptians and their Book of the Dead, or even ancient Greek philosophers like Plato, they frequently described sleep as a temporary separation of the soul from the body. They basically likened it to a miniature reversible death. But today we actually have the tools to look at this through the lens of modern neuroscience to see exactly what the hardware in your head is really doing. Section 1. Inside the sleeping brain, the neurobiology of sleep. So, modern neuroscience breaks down this daily temporary death into a very active, highly structured biological process. Your brain absolutely does not just shut off. Instead, it meticulously cycles through several distinct stages. First, we drop down into non-rapid eye movement, or NREM sleep, moving from light drowsiness right into deep, slow-wave sleep. And then, boom, we rocket back up into REM, or rapid eye movement sleep, which is exactly where our most vivid dreams actually happen. This whole cycle loops every 90 minutes, repeating about 4 to 6 times a night, fundamentally altering our muscle tone and brain waves with just incredible precision. Moving on to Section 2, the out-of-body glitch, sleep paralysis. So what happens when that super precise neurobiological machinery makes a mistake? Well, it turns out up to 50% of the population, that's literally half of everyone watching this, will experience a genuinely terrifying glitch known as sleep paralysis at least once in their lifetime. According to sleep researchers, this often comes complete with the sensation of immense chest pressure, or the absolute bone-chilling certainty that there is some kind of supernatural presence, like a sleep demon or intruder right there in the room with them. Now, for centuries, this was blamed on ghosts or witches, but the truth? It's deeply rooted in our biology. And this perfectly illustrates a biological phenomenon called REM atonia. See, during that REM sleep phase where your dreams are getting wild and vivid, your brain actually floods your body with neurotransmitters that cause temporary muscle paralysis. It's basically a protective chemical lockdown, so you don't go physically acting out your dreams and accidentally hurt yourself. But in sleep paralysis, your conscious mind wakes up while that chemical lockdown is still fully active. You are literally trapped inside your own biological spacesuit. But wait, why the floating out-of-body sensation? Well, when REM atonia overlaps with waking awareness, it scrambles a very specific part of your brain called the temporoparietal junction. Now, this region is responsible for processing your body map, basically your sense of where your physical self is located in space. So when it gets conflicting signals, your mind screaming, "Hey, I'm awake," and your muscles saying, "Nope, we're paralyzed," it creates a massive neurobiological glitch. Your brain frantically tries to resolve the conflict, and the result is this incredibly vivid, eerie hallucination that you are floating right out of your own physical body. Okay, Section 3. Anesthesia, the artificial sleep state. Once we understood how the brain naturally shuts off consciousness, human ingenuity, of course, figured out how to artificially hijack this exact state. If we compare the two, natural sleep is driven by our internal circadian rhythms, our biological clocks just reacting to light and dark. Clinical anesthesia, on the other hand, uses powerful drugs like propofol. Research from places like the University of Cambridge shows that anesthesia induces behavioral unresponsiveness by artificially mimicking sleep. It effectively breaks down the functional connectivity in our cortex. Basically, the different parts of your brain literally stop talking to each other, totally suspending your consciousness on demand. Which brings us to Section 4, the edge of death, brainwaves. But what happens at the absolute edge of existence, like during an actual cardiac arrest? To really understand this, we need to quickly talk about brainwaves. At the lower end of the spectrum, we have slow delta waves, between 1 and 4 hertz, which indicate deep unconsciousness and slow wave sleep. As we move through theta, alpha, and beta, the brain gets progressively more active. And then we have incredibly fast gamma waves, clocking in at over 30 hertz. Gamma waves are the signature of a highly active cortex. They're the brainwaves of intense concentration, high-level perception, and hyper-focused attention.
Now, logic would dictate that as a person dies, their brainwaves would just slowly fade out to flatline delta waves, right? Well, astonishingly, recent EEG data captured from dying patients shows the exact opposite. As reported in major scientific journals, there is a massive last-second surge in gamma wave activity in the human brain during cardiac arrest. Just as the oxygen supply is completely cut off, the brain literally explodes with the exact electrical frequencies associated with intense, highly vivid conscious experience. It's wild.
So the really crucial takeaway here is that this paradoxically heightened electrical activity provides a rigorous scientific explanation for near-death experiences. When patients are resuscitated from clinical death, they often report these vivid spiritual visions, sensations of moving toward a light or peacefully leaving the physical world. Well, the data suggests these aren't just cultural myths. They are incredibly real, subjective experiences generated by the dying brain's final, desperate surge of high-frequency gamma coherence right before it permanently powers down. And that leads us to Section 5, the science of the soul, a final conclusion. How do we even begin to define something as historically profound as the soul when we have all this hard neuroscience in front of us? As one source powerfully summarized the current neuroscientific view, we basically exist as a temporary structure in the universe. If we are just biological machines, then our consciousness, our emotions, our memories, and our whole identity are simply the result of a precise arrangement of matter. It's perfectly compared to a smartphone. Once the hardware breaks down, everything on it is destroyed. There's no hidden backup in the cloud, no persistent soul hovering somewhere else. The unique configuration that sustains your subjective experience is tied directly to the biology of your brain.
So if the profound feeling of our soul leaving our body during sleep paralysis is just a fascinating glitch in the temporal parietal junction, and if the classic white light of death is actually just a final surge of gamma waves, I want to leave you with this one provocative thought to ponder. If your consciousness really is just a precise, incredibly fragile arrangement of biological hardware, where do you really go when your hardware powers down tonight? Thank you so much for exploring this explainer with me, and as always, never stop questioning the mysteries of your own mind.